Bon après-midi. Mon nom c'est Jorge, Sebastiao. Ça me fera plaisir d'être avec vous pour à peu près 45 minutes cet après-midi. C'est toujours difficile vers la fin de la journée, surtout avec une chambre aussi chaude. Alors c'est bon de distribuer un peu de glace à travers l'audience. Quoique je parle français, je peux prendre des questions en français, en espagnol, un peu portugais, peut-être un peu en simple arabe. La présentation va être en anglais. Alors s'il y a des questions, ou si je vais trop vite, bon, on prendra un petit peu vers la fin. Alors ça fait plaisir d'être ici. Et, the topic of my discussion today is something called Weapons of Mass Destruction, I guess version 4, maybe similar to IPv4, but it's an evolution of a presentation that has been growing over time. Of course, trying to make this as interesting as possible, the topics that I'll be covering is, obviously there's a lot of attention being put to that. Although I come from Canada originally, most of my work has been done around Middle East, Africa, and Asia. We sometimes tend to refer these as emerging markets, depending on which perspective. Of course, around the Middle East, these kind of attacks and this kind of technologies is extremely important because we're looking about protecting critical infrastructure. And here, when I refer to critical infrastructure, I primarily talk about oil pumping business, which obviously is helpful for the rest of the world. We'll look at target attacks, specifically Stuxnet and upcoming variations and some of the implications. When we look at this new world order, I guess we can look at from the cinema perspective or Hollywood, but in reality, in the real world, things are slightly different, or maybe not so slightly different, as we can see a lot of similarities between what is happening on the big screen as well as in reality. Of course, these kind of attacks are not new. We'll pick one or two in particular. More specifically, if you go back a few years, the CIA actually took a specific chip and introduced some logic bomb in it, which destroyed a gas pipeline. And as you can see, this kind of attacks have a direct implication on the economical consequences of a country. At that time, Russia was coming out of tough economical times. If somebody destroys the capability of you collecting cash to feed your people, the implications are extremely high. More specifically, at Stuxnet, it started appearing a little bit sometimes in a funny way, but we'll refer to this in more detail later. But what you actually see on the screen is not exactly what is always happening in real time. Now, it started appearing in the press somewhere between 2010, 2011, but in reality, the attacks predated much earlier than that. We're talking probably 2008 or even earlier, or at least 2008 as documented. These kind of attacks, as we tend to refer them, maybe from a statistics perspective, an earlier speaker also alluded to that, they call them persistent targeted attacks, which is really funded by people that can afford it because it takes a long time. They require a lot of customizing and investment, much well beyond the capabilities of much of the networks that we have been referred to. And they typically tend to target infrastructure of a country. If you look at Estonia a few years back, you can look at this as the public sector being targeted, but specifically Stuxnet, it looks at things like manufacturing or critical infrastructure of a country. When we look at traditional mass attacks that are maybe designed to collect small amounts of money, which turns out to be a lot, when we look at targeted attacks, there is very unique features associated with that. The way they actually propagate across the network, the way they attack the network, the way they choose the victims, and how they take the information from those victims or how they create destruction within that environment. And the idea here behind a lot of these attacks is not to be perceived, because once the attack gets known, you have to move on and reinvent the wheel to attack further. Specifically to Stuxnet, when it was discovered around 2010, at the time we talked of it as a complex attack, over 100,000 lines of code, but we'll see very quickly that more complex attacks are coming on board. It used zero-day exploits or specific vulnerabilities against the Microsoft operating system, one would look at, well, why infrastructure industrial attack will actually attack a Windows operating system. One would not expect the two to coexist, but there is actually a very tight connection between and the reasoning behind it. And the reason is the Windows operating system is the tool that is actually being used to program the logic control unit, which is actually driving the industrial system that in this case is being infected and being destroyed. Now, it's always nice to try to describe things in slides, but I think in the case of real life, it's always better to actually see a video that puts things in perspective. So I've chosen two videos during my presentation, so I'll play the first one.
7 software installed, and you need that software in order to access the PLC and to program the PLC. Here's the PLC that we're actually going to program. We're going to download our program on here, and we're going to show how we can control the PLC. The PLC is connected to this air pump, and we're going to use this air pump to inflate balloons, and we're going to use proof of concept code to show how Stuxnet would be capable of interfering with the process of programming the PLC and controlling the pump. So the demonstration that I'm going to show is I'm going to program the PLC to inflate this balloon for 3 seconds. Then we're going to infect the PLC, and we're going to download the same program to inflate the balloon for 3 seconds again. But when the computer is infected, you'll see that the PLC behaves differently from what we expect. So to program the initial PLC to inflate the balloon for 3 seconds, I use the software step 7. So in step 7, you need to open up the code block OB1. And inside in the code block OB1, I have this timer here set for 3 seconds. 3S is the important command here. This timer is going to run for 3 seconds. It'll turn the pump on until this timer is finished, and when the timer is finished, it'll turn the pump off. That's turning the pump off here. So what I do is I download that onto the PLC. And it asks me, do I want to overwrite the code that is already there? I say yes. Okay, so now this code is on the PLC, so we can test our code out by turning on the PLC. So we see that the code worked as we expected it to work. The balloon inflated for 3 seconds. So now what we're going to do is we're going to infect the PLC, we're going to infect the computer here, we're going to download the same program onto the PLC, and we'll see that the PLC behaves differently the next time. So to do that, I need to close all the software, infect the machine, and then open up the software and perform the same steps again. So here again we look at OB1, we see that our code still says 3 seconds, and we're going to download this onto the PLC again. At this stage the computer is infected, so we don't have control of the PLC. So what we think we're sending to the PLC can be intercepted by the threat and can be rewritten. So it's asking me, do I want to override the code that's already there? I say yes, the same as last time. So now this code here that will run for 3 seconds and inflate the balloon for 3 seconds, that's what we should observe here when we turn on the PLC.
I guess when you see this pop happening to your own industrial systems, you kind of get the picture. What it really means is that the operator is obviously looking at the screen in front of him. Everything appears to be operating correctly, but what is actually happening behind the scenes is something completely different. So Stuxnet, created somewhere around 2008 or earlier, went through a series of steps until it was actually discovered, but the primary objective was actually to infect the PLC. More specifically, to infect a specific Siemens-made PLC which is the one that is actually was being used in Iran. So it was actually targeting what's called WinCC, which is the controlling system used to program the PLC. It used a several rootkit approach with zero-day non-known Windows attacks. And one would expect these kind of industrial systems not to obviously be connected to the internet. So the original infection was done via USB. So it combined various techniques, obviously not traditional infection as we see today. And once it infected a particular machine, then it could easily propagate through the network and look for the proper targets. And it created a botnet which could be controlled remotely. It could be remotely updated with refreshes of the attack, etc. So if we look at the overview of this particular attack, the target was a nuclear plant. The victim was a specific country called Iran. The motivation was actually to delay or destroy as much as possible the centrifuges which are used to enrich the uranium. Obviously, the compromise was based on a combination of traditional attacks, as some of the previous speakers have talked, but also on social engineering, which was a previous talk as well, because it involved the use of a memory stick, and it involved specific vulnerabilities both on the Windows and the Siemens system. Now, result was over 1,000 of these centrifuges got destroyed, delayed the program, and after some time, organizations like Siemens were forced to actually patch their system as well. So this entire propagation system obviously started with the infection via a USB stick, which means there obviously had to be some compromise of specific resources which had physical access to the plants or the enrichment plants in these locations. Once this was done, then it used to propagate via USB, via a print server or via Windows server, zero-day attack, and then simply propagate across the local area network, which one would not expect it to actually be connected to the internet. And from there on, it obviously created as much damage, and we'll see a specific example of how that damage was done. Today, one can actually test for this specific attack. It is available on the Metasploit toolkit, so you can easily do a simulation of such attack. Other things that are probably important to note is these kind of attacks, as some of the ones I will be talking later on in the presentation, use anti-forensic techniques. They are designed to remain as hidden as long as possible. And they are trying to be very, very targeted, and they basically hide their tracks as best as possible so they are not becoming discovered earlier on. This is what the Siemens Thematic PLC looks like. You have the control system that you saw earlier, which is a Windows user interface, which is called WinCC. Once the right programming is done of the PLC, then the program gets transferred across. The interesting aspect about this specific attack is that the operators in the Iran enrichment plants were looking at the console that controlled this PLC, and everything basically seemed to operate as it was before. So they were basically hiding the feedback. So the operators saw everything as running normal within the plant. Another interesting aspect about the attack was the amount of research and funding that went into doing this attack. In the first part of the presentation, I looked at the propagation, affecting Windows with zero-day exploits, but to actually attack Siemens-made industrial-grade tool, it requires a lot of research. And this research was basically done using resonance. I don't know if many of you are familiar with the term resonance, but anything that is built today, whether it's a car, a building, or a bridge, has a resonance frequency. And if you can reach that resonance frequency, basically that building, that car, etc., will self-destruct. The best way to actually try to describe this to you is to show you another quick video. So everything that exists has a specific frequency. What really happens is when you actually reach that frequency, which is different for each object, the object basically becomes completely unstable. So you can imagine what was going inside those centrifuges when you reach the right level of frequency. is important to highlight here, you can quickly imagine the amount of research, testing that went on to actually make sure that the exact amount of damage was actually being done. So you had to have access, also you had to have very tight cooperation with the engineers that actually built these centrifuges in the first place as well. So in the case of this specific device, when it reached a certain frequency, these devices were basically self-destructing. Now, you don't want to be one of these centrifuges, of course. The interesting aspect is also how this got distributed. It quickly became clear that this was targeted at specific countries. But of course, as any malware that is created, although it might be with a specific purpose, it tends to always outspread its bounds. So it actually infected other locations like India, Indonesia, etc. So although the primary large number of attacks were in Iran, other countries like Indonesia and India got extremely affected as well, although in smaller numbers. And also this got infected as well in specific countries where also the Siemens was being used. So you can quickly imagine that if you were sitting in South Korea or so, your system might actually be infected and you have a side effect, and you are basically being called, sometimes I think we tend to refer to this today as collateral damage. So now, obviously the result was the attack on this specific critical infrastructure, specific enrichment in nuclear plants in Natanz and Bushiri. It caused 60% infections in Iran. And obviously the objective here was to delay this specific program. This was still earlier on. No country at that time claimed responsibility for any of such attacks. As a result, Siemens, after long periods of time, was forced to actually patch the system. And what basically started to happen is everybody started looking. If this can happen in Iran, what about our own critical infrastructure? We run electrical plants, we run water plants, we run trains, we run all kinds of systems that have SCADA systems built in. And these own systems have obviously vulnerabilities associated with them. And what is really important here to note at the end of the day is any kind of attack you launch is